Hello, this is Clyde, BraceBlogger podcast number 43. This is out of the March 2018 O&P Almanacs in the Happenings section, page 10. Research Roundup. Researchers test strategies to improve post-stroke rehabilitation. A team at Northwestern University is developing stroke rehabilitation interventions that promote the use of the affected side of stroke patients to improve movement control. Nearly 80% of stroke survivors experience hemiparesis, or one-sided weakness, and suffer from the loss of fine motor control in the arm and hand on the opposite side from where the damage occurred in the brain. Northwestern researchers noted that when a stroke survivor attempts to move the affected arm, activity in the brain switches from the affected side to the non-affected side, which normally controls movement of the opposite arm. While this allows the brain to tap into backup motor systems that bypass regions damaged by stroke, this process also involuntarily activates the elbow flexor muscles, a common motor impairment known as quote, flexion synergy, unquote. In a study published in a recent issue of the Journal of Physiology, the Northwestern team detailed its use of a robotic device to encourage the brain to use the affected side to improve movement control and reduce the effects of flexion synergy. The team is investigating rehabilitation devices that begin by unweighting the affected arm and then progressively increase the weight of the arm across therapy sessions as reaching function improves. The study involved using a robotic device to control shoulder effort and precisely measure reaching movement with accurate identification of the location of brain activity in real time through the application of 160 electrodes on each participant's head. Quote, we plan to study the use of the non-affected side of the brain and associated indirect motor pathways during early recovery from stroke, unquote, explained Julius DeWald, PhD, principal investigator on the project. Quote, we will do this by progressively increasing the weight of the affected limb while measuring reaching performance at set times during the recovery process. The neural mechanism underlying the flexion synergy phenomenon is believed to be mediated by indirect motor pathways via the brainstem from the non-affected side of the brain. We are also investigating whether targeted drugs can manipulate these backup motor systems post-stroke, which could ultimately open a door to new therapies to aid physical rehabilitation, unquote, said DeWald. Next article, eSkin promotes sense of feel in prosthetic limbs. Scientists at the University of Colorado Boulder have developed electronic skin, or eSkin, a thin, semi-transparent material designed to measure temperature, pressure, humidity, and airflow. The eSkin mimics functionalities and mechanical properties of natural skin and can be used in conjunction with prosthetic devices, according to the research team, which was led by Jiangliang Zhao, assistant professor of mechanical engineering. The dynamic covalent thermoset-based eSkin is connected through robust covalent bonds and has tactile temperature, flow, and humidity sensing capabilities, according to the researchers. The skin has been designed to re-heal when damaged and can be recycled at room temperature, after which it regains mechanical and electrical properties comparable to original eSkin. eSkin has quite broad applications in a sense to enable sensation of otherwise passive systems, including prosthetic applications, said Zhao. After the skin is wrapped around a prosthetic hand, for example, the eSkin could enable the prosthesis to sense for pressure when holding a glass cup, according to Zhao. The material also has applications for future robots. A full study on eSkin titled, quote, Rehealable fully recyclable, and malleable electronic skin enabled by dynamic covalent thermoset nanocomposite, unquote, was published in February in Science Advances. Next article, Access AOPA member-funded research on shared decision-making. A recent issue of Prosthetics and Orthotics International features research conducted by Michael Dillon, PhD, of La Trobe University and funded by AOPA. The study explores the topic of shared decision-making, a consultative process designed to encourage patient participation in decision-making by providing accurate information about treatment options and supporting deliberation with the clinicians about treatment options. Access the abstract of the article titled Development of Shared Decision-Making Resources to Help Inform Difficult Healthcare Decisions, an example focused on divascular partial foot and transtibial amputations at bit.ly Dillon Research. Last article, Facilities Seek Partial Payments via Low Volume Appeals Initiative. The Low Volume Appeals Initiative, LVA, a new program in place from CMS and the Office of Medicare Hearing and Appeals, has been designed with the intention of reducing the number of pending appeals. The LVA program is geared toward patient care facilities that have fewer than 500 appeals pending an administrative law judge level or higher, with each appeal having a billed amount of no more than $9,000. Participants in the program might file an expression of interest for a limited settlement agreement. If approved, the agreement will result in a timely one-time partial payment of 62% of the net Medicare approved amount of the appeals in question. Those suppliers whose National Provider Identifier NPI numbers end in an even number 02468 must file an expression of interest by March 9, 2018 to participate in the program. Those suppliers with an NPI ending in an odd number may take part in the LVA program between March 12th and April 11th, 2018. And that's the end of the happening section in the March edition of the O&P Almanac. This is the end of podcast number 43 by BraceBlogger.com.